Hello student, this is Lotif sir. Today I will discuss about ISC class 12 chemistry. The topic is solution chemistry. Second chapter of class 12 chemistry. The topic is solution. So we know that solution is a homogeneous mixture of two or more substance. Solution is a homogeneous mixture of two or more substance in same or different physical phases. And the substances forming the solution are called component of the solution. The substances which forms the solutions are called components of the solution. If there are two components of a solution, then the solution is known as binary solution. Okay, so on the basis of number of components of a solution of two, if two components, then it is called binary solution. You have to remember. So first, you have to see what is solute and solvent. Solution is generally made up of two components. A binary solution is made up of two components. One is solute and another is solvent. What is solute and solvent? In a binary solution, solvent is the component which is present in large quantity. In a binary solution, a solvent is the component which is present in large quantity, while the solute is the component which present in a small quantity. Okay. So, for example, in salt water, water is solvent and salt is solute. Now, classification of solution. Following types of first see A. Following types of solution are seen on the basis of physical state of solute and solvent. On the basis of physical state of solute and solvent, this is the classification of solution. First, serial number or types of solution. Second column, solute. Third, solvent, and fourth, example. Let's see the box. First type of solution is solid solution, second liquid solution, third gaseous solution. And the classification is based on the nature of solvent. In solid solution, the nature of solvents are solid. In liquid solution, the solvents are liquid, and in gaseous solution, the solvents are gas. Okay, so in case of solid solution, there are three types: solid in solid solution, that is solid, both solute and solvent are solid. Liquid in solid, that is solute is liquid but solvent is solid. Gas in solid, that is solute is gas and solvent is solid. Okay, so let's see the example. Solid solution. Solid There are three types of solid solution: solid in solid, example alloy, metal alloy. Okay, there are in alloy, two or more metals make a homogeneous solution. Okay, in which both components are metal, that is solid. So solid in solid, example is alloy. Liquid in solid, example is amalgam of mercury with sodium, amalgam of mercury with sodium. Gas in solid, dissolved gases in mineral, example of gas solid solution in which solute is gas and solvent is solid, is example is dissolved gases in mineral. Second one, liquid solution. In liquid solution, solvents are liquid, but solute may be solid, liquid, or gases. So, in liquid solution, solid in liquid, example salt solution in water. Here, water is solvent, liquid, and salt NaCl is solid, solute. Liquid in liquid, alcohol in water is a solution in which both solute and solvent is liquid. Gas in liquid, aerated drink. Okay, and last one, gaseous solution. Example, there are three types of gaseous solution: solid in gas, liquid in gas, gas in gas. Solid in gas, example iodine vapor in air. Liquid in gas, example water vapor in air. And gas in gas, example air, in which different gases are mixed, O2 plus N2. Now If water is used as solvent in a solution, if water is made up as solvent, used as solvent, then the solution is called aqueous solution. And if the solution uh, n- is not done in water, then the solution is called non-aqueous solution. That is, if water is used as solvent, then the solution is called aqueous solution, and if not, then the solution is called non-aqueous solution. Now, depending upon the amount of solute dissolved in a solvent, we have the following types of solution. Depending on the amount of solute dissolved in a solvent, we have the following types of solution. There are three types of solution depending upon the amount of solute dissolved in a solvent. First, unsaturated. Second, supersaturated solution. Third, second, saturated solution, and third, supersaturated solution. So let's see what is a unsaturated solution. A unsaturated solution is a solution in which more solute can be dissolved without raising temperature. A solution in which more solute can be dissolved without raising temperature is called unsaturated solution. Second one, saturated solution. Saturated solution is a solution in which no solute can be dissolved further at a given temperature is called a saturated solution. Saturated solution is a solution in which no solute can be dissolved further at a given temperature. And supersaturated solution is a solution which contains more solute than that would be necessary to saturate it at a given temperature is called a supersaturated solution. So supersaturated solution is a solution in which contains more solute than that would be necessary to saturate it at a given temperature is called supersaturated solution. Next point, solubility. Solubility is the maximum amount of solute. Solubility, it is the maximum amount of solute that can be dissolved in a given amount of solvent, generally in 100 ml 100 gram of solvent. Okay, so solubility is the maximum amount of solute that can be dissolved in a given amount of solvent, generally in 100 gram, at a given temperature is called its solubility. At that temperature, you have to remember the temperature must be constant during the calculation of solubility of a substance. Okay, so the solubility of a substance or solute in a liquid depends upon the following factors. The factors are nature of solute, nature of solvent, temperature of the solution, pressure in case of gas. Huh. Solubility of gas depends on pressure. Huh. We and the last point, to explain the last point, you have to read the Henry's law. So, what is Henry's law? It is actually applicable for dissolution of gases in liquid. Okay, when gases are dissolved in liquid, uh, you can apply Henry law to state the solubility of the gas, how the solubility of the gas depends on the pressure of the on the gas. Okay, so Henry's law, the most commonly used form of Henry's law, states the law is the partial pressure of the gas in a vapor phase is proportional to the mole fraction of the gas in the solution. That is, partial pressure P is directly proportional to the mole fraction, that is X, mole fraction of the solute or of the gas. Here solute is gas, okay, and solvent is liquid. So still, Henry's law is the partial pressure P of the gas in vapor phase is proportional to the mole fraction of the gas in the solution, and it is expressed as P directly proportional to X, that is P is equal to kH into X, where kH is a constant which is called Henry constant. And what is the characteristic of Henry constant? Greater the value of kH, Henry constant, higher is the solubility of the gas. Different gases have different kh value. Okay, and those gases having higher kh value will be more soluble in water. Okay, and the value of kh decreases with increase in temperature. Second point, the value of Henry constant decreases with increase in temperature. That's why aquatic species are more comfortable in cold water, because cold water dissolve more oxygen. We know that higher the temperature, less is the solubility of the gas. Okay, and solubility depends on pressure of the on the gas. Higher the pressure, more is the solubility. Thus, aquatic species are more comfortable in cold water. That is, more dissolve oxygen in cold water rather than in warm water. Warm water contains less amount of oxygen. Okay. And last, application of Henry's law. The last topic is application of Henry's law. Henry's law it is applicable in the making cold drinks. Okay, soft drinks. So in the manufacture of soft drinks, the soda water in the manufacture of soft drinks and soda water, carbon dioxide is passed at high pressure to increase the solubility of the gas in water. In manufacture of soft drink and soda water, carbon dioxide is passed at high pressure to increase the solubility. Second application is to minimize the painful effect accompanying the decompression of deep sea divers. Oxygen diluted with less soluble helium gas is used as breathing gas. And third application is at high altitudes, the partial pressure of oxygen is less. The partial pressure of oxygen is less than that of ground level. This leads to low concentration of oxygen in the blood of climber, which causes anorexia. Okay, these are the application of Henry's laws. Thank you.